A very good morning, good afternoon, or good evening to all my dear students. I hope you all have understood the properties of inverse trigonometric functions that I have taught in the previous lecture, that is in part 1. So today I am going to explain the remaining properties. I am going to play the slideshow of the properties of inverse trigonometric functions on the screen, and so you have to pay complete attention. In these properties, again you have noted the same thing in common. What is it? It is the range of values for x which is given again. So let's take up the first property. It is sine inverse x plus cos inverse x is equal to pi by 2. Here, the range of values for x is from -1 to 1. Means if and only if the value of x is in between -1 to 1, then only you can apply this property, then only you can use it. So let's see its proof. The first step is you have to let sine inverse x equal to theta. So x will be sine theta. Sine inverse from LHS to RHS will become sine and it will get attached to the entire RHS. So here in this case RHS is theta. So sine inverse came here, became sine and attached to theta, sine theta. So can you write sine theta as cos pi by 2 minus theta? Yes, you can write. It is again a property. Sine theta is equal to cos pi by 2 minus theta. So, what is the next step that you have to do is, you have to take cos again from RHS to LHS. So, it will become cos inverse attached to x, cos inverse x is equal to pi by 2 minus theta. It is pi by 2 minus, in place of theta you can write sine inverse x. Pi by 2 minus sine inverse x. Now, here you are having cos inverse x. So just take up this sine inverse x from RHS to LHS. See, this is a property. Sine inverse x plus cos inverse x is equal to pi by 2. Let's move on to the next property. It is tan inverse x plus cot inverse x is equal to pi by 2. What is here the range of values for x? It is the set of all the real numbers. Means any real number could be in place of x in this property. If it is so, if it is a real number, then you can use this property. So its proof is also the same type. Tan inverse x is equal to theta. So x is equal to tan theta. So again, can you write tan theta as cot pi by 2 minus theta? Yes, it is again a property. Tan theta is equal to cot pi by 2 minus theta. So, just take this cot from RHS to LHS. Minus theta. Again in place of theta, what you have to do in place of theta, the substitute the value of theta from step 1. It is tan inverse x. So So cot inverse x is equal to pi by 2 minus tan inverse x. Just take this tan inverse from RHS to LHS and you got the property. See, the proofs are very simple and so are the properties. The only thing that you have to keep in your mind, just remember it very firmly, is the range of values for x. In this case it is x belongs to R, the set of real numbers. So this is the property. Again, the next property is cosec inverse x plus sec inverse x is equal to pi by 2. This property I'm not going to write its proof. You have to prove it on your own. Okay? So it's left as an exercise for you. Let's take up the other type of properties. You have to do this. This is your own work. Tan inverse x plus tan inverse y is equal to tan inverse x plus y upon 1 minus xy. This is the property. What is it? Tan inverse x plus tan inverse y is equal to tan inverse x plus y upon 1 minus xy. So if xy is less than 1, it is written here. This is the particular thing that you have to keep in your mind. You have to here keep in mind that xy should be less than 1. Then only you can apply this property. So let's see its proof. Here you have to let two things. First is you have to let tan inverse x, let it be theta. Then x will be tan theta. And second is you have to let tan inverse y, let it be phi. Then y is tan phi. Okay? So what is the next step that you have to do? So see, this became tan inverse x became theta plus tan inverse y became phi. So theta plus phi you are getting here. So now you have to take tan theta plus phi. What you have to do now? You have to write tan theta plus phi. So it is tan x. What is it? Tan x plus phi. What is the formula? Tan theta plus tan phi upon 1 minus tan theta into tan phi. So in place of tan theta, can you write x? Yes. Then in place of tan phi, you can write y upon 1 minus xy. Tan theta is x and tan phi is y. So this is what? This is tan theta plus phi. So now if you take this tan from RHS to LHS, what will it become? Tan inverse x plus y upon 1 minus xy. Tan inverse x plus y upon 1 minus xy. Tan came from RHS to LHS and became tan inverse and got attached to the entire LHS. What is left here? Here it is left theta plus phi. Theta and phi are tan inverse x. Theta is tan inverse x plus phi is tan inverse y is equal to what you have got. Tan inverse x plus y upon 1 minus xy. See, tan inverse x plus y upon 1 minus xy is equal to theta plus phi, which is tan inverse x plus tan inverse y. This is the property. Okay. So the next property is tan inverse x minus tan inverse y. The same. This proof is also the same as the above one. Just here also you have to let tan inverse x as theta and tan inverse y as phi. And then you just have to apply here tan theta minus phi. Okay, so I've told this much. You have to prove this property on your own. So let's move to the other type of properties. This 2 tan inverse x is equal to sine inverse 2x upon 1 plus x square. Here also you have the range of values for x, and it is in this case mod of x should be less than 1. Remember all these properties, you have to learn them. So here also what you have to do, you have to let a portion of LHS. You have to let tan inverse x. This tan theta. Now you have to apply this in the RHS. In place of x, you have to write tan theta in the RHS. Now sine inverse inside, what is it? In place of x, you have to write tan theta using 1. 2 tan theta upon, again in place of x you have to write tan theta. So here you have x square, so it is tan square theta. So now have you remembered what is this? It is the formula of sine 2 theta is equal to, sine 2 theta is equal to 2 tan theta upon 1 plus tan square theta. So what will you do here? In place of this you will write sine 2 theta using this identity. So it is RHS is equal to sine inverse sine 2 theta. Now using the property that I have told you all in the previous lecture in part 1, what was that? It was sine inverse sine x is equal to x. Sine inverse sine x is equal to x. So here also you can write sine inverse sine 2 theta as 2 theta. In place of theta you can write tan inverse x. Isn't it? See? This was what you have left. Tan inverse x as theta. So in place of theta you can write so. So what your RHS has become 2 tan inverse x. Your RHS has become this. And see what was your LHS? Your LHS was 2 tan inverse x. So you can write RHS equal to LHS. Hence it is proved. Let's take up the other property. So here, what is the range of values for x? It is mod of x should be greater than or equal to 0. So let's try it. First step is you have to let tan inverse x is equal to theta. X is equal to tan theta. Then in place of, then you have to do the RHS. In place of x, you have to write tan theta. Wherever you get x in the RHS, you just have to write tan theta in place of it. So what is our RHS? It is 1 minus x square upon 1 plus x square. 1 in place of x you have to write tan theta. It is tan square theta upon 1 plus tan square theta. Now again, what is it? It is the formula for cos 2 theta. All the properties used in the proofs, all the identities which I am using in these proofs are those which you must have studied in class 11th. So are you seeing? Revision is very important. Keep revising your previous class courses as well. So what is the identity? Cos 2 theta is equal to 1 minus tan square theta upon 1 plus tan square theta. So you were solving your RHS, and what it has become now? RHS has become cos inverse. In place of this, cos 2 theta. Cos inverse cos 2 theta. Now again, what you have to do here? This is a property. Cos inverse cos x is equal to x. Okay. So RHS is equal to cos inverse cos 2 theta. In place of this, you can write 2 theta. Using this property, cos inverse cos 2 theta is equal to 2 theta. Now in place of theta, you can write tan inverse x. See, you have let it. Tan inverse x is equal to theta. So in place of theta, you wrote 2 tan inverse x. So this is what? This is the LHS. So your RHS has become the LHS. That means you have proved it. LHS is equal to RHS, hence proved. Last and also the least property is 2 tan inverse x equal to tan inverse 2x upon 1 minus x square, where mod of x is less than 1. Here what you have to do, again you have to let tan inverse x as equal to theta. Then what will be x? X is equal to tan theta, and then you have to take up the RHS, and in place of x you have to write tan theta. Then the proof is as simple. And here also you have to use an identity from class 11. So this one I am not going to do. This I am giving as an exercise for you to do. Okay? So try it on your own, and if you get any difficulty, just comment it to me. Okay, so subscribe my channel for the latest updates. Share my video among your friends and your classmates.